In this video, we're going to look at a word problem that involves separable differential equations. All right, so what we have here is a tank contains 30 kilograms of dissolved salt in 1,000 liters of water. A brine solution, which is basically salt water, with salt concentration of 10 grams per liter, is pumped into the tank at rate of 20 liters per minute. The solution is well mixed and drains from the tank at the same rate of 20 liters per minute. So notice that the volume of solution in the tank never changes because the rate of solution that's coming in is 20 liters per minute and the rate of solution that's leaving the tank is also 20 liters per minute. So the solution in the tank will always be 1,000 liters, the volume of the solution. But of course the mass of salt in the tank is going to change as time changes. So part A of the question asks us how much salt is in the tank after t minutes. Part B asks us how long will it take for the concentration of salt in the tank to be reduced to 20 grams per liter. Let's do part A first. So for part A, we have x of t is equal to mass in kilograms of salt at time t. So mass in kilograms of salt. Initially, we have 30 kilograms of dissolved salt. X of 0 is equal to 30 kilograms. Now, let's find the rate of salt that's entering the tank. The rate of salt that's coming into the tank, rate of salt in, is equal to, we have 10 grams per liter, that's the concentration of salt that's coming in, multiplied by 20 liters per minute, that's the amount of solution that's entering the tank. We multiply these two quantities, liters cancels out, and we get 200 grams of salt coming in every minute. Let's change that to kilograms. There's 1,000 grams in a kilogram, so the rate of salt that's coming in, rate in, is equal to 0.2 kilograms per minute. Now the volume of the salt in a tank, so the volume of salt in tank is always going to be 1,000 liters at all times. So let's find the rate of salt that's exiting the tank. So rate out is equal to, that's going to be the concentration of salt that's coming in, x over 1,000 kilograms per liter. This is the concentration of salt that's coming into the tank. Sorry, this is the concentration of salt in the tank at time t, multiplied by the amount of solution that's leaving the tank. And when we multiply these two quantities, we get the kilograms of salt that's exiting the tank. This is really important, so I'm going to repeat myself. So x over 1,000 kilograms per liter is the concentration of salt in the tank at time t. This is the concentration. 20 liters per minute is the amount of solution that's leaving the tank. If you take the concentration of salt in the tank at time t, multiplied by the amount of solution that's leaving the tank, we get the amount of pure salt that's leaving the tank. So this is equal to 0.02 x kilograms of salt that exits the tank every minute. So the rate out is the concentration of salt at time t multiplied by the amount of solution that's leaving the tank. All right, so dx dt is equal to rate in minus rate out. So dx dt, this is the rate of change of mass of salt that's coming in every minute. Rate in is 0.2 kilograms per minute. Rate out is 0.02x kilograms per minute of salt. And x of 0 is equal to 30 kilograms. Initially, there's 30 kilograms of salt dissolved in the tank. So we now have a differential equation that's separable, and we can solve for x as a function of time. So let's separate out the variables. Dx divided by 0.2 minus 0.02x is equal to dt over 1. We have separated the variables. Now let's integrate both sides. So we have x on the left-hand side, t on the right-hand side. We can do the integration. So to do this integration, we're going to apply U substitution. Let u be equal to 0.2 minus 0.02x. Differentiate, we get du is equal to minus 0.02 dx. Solve for dx, and we get dx is equal to du divided by negative 0.02. Sorry, let me fix that. Dx is equal to du divided by negative 0.02. All right, so what we have is integral. We have the denominator, that's just u, and dx is going to be du divided by negative 0.02. On the right-hand side, if you integrate 1 dt, that's just t plus c, reversing the power rule, I guess. So now what we have is 1 divided by negative 0.02, that's negative 50. Remove it outside the integral, we get negative 50. Integral 1 over u du is equal to t plus c. So we have negative 50, integral 1 over u du is equal to t plus c. Now integrating the left-hand side, we get negative 50. What is the antiderivative of 1 over u? That's just log of u. And the right-hand side has already been integrated. Let's isolate log of u. So we get log of u is equal to negative 1 over 50 times t. Divide both sides by negative 50 minus c over 50. Now exponentiate both sides, and we get e to the log of absolute value of u is equal to e to the negative 1 over 50t minus c over 50. We exponentiate both sides so we can recover u, so we can get rid of the log function. So we have absolute value of u is equal to e to the negative 1 over 50t times e to the minus c over 50. We separate the exponentials using exponential law. So now let's write this as absolute value of u is equal to k times e to the negative 1 over 50t. Because all of this, e to the minus c over 50 is a constant, we just replace that by k. Now let's remove the absolute value, and we get u is equal to plus or minus k e to the negative 1 over 50t. And plus or minus k, we can just change that to b. Let's say b is equal to plus or minus k. And b will be determined from the initial condition. So we have u is equal to b e to the negative 1 over 50 times t. Now let's substitute u back in. U is equal to 0.2 minus 0.02x. So we get, on the left-hand side, we get 0.2 minus 0.02x. On the right-hand side, we have b e to the negative 1 over 50t. Okay, so now what we have is, let's solve for x. We have negative 0.02x is equal to b e to a negative 0.02t minus 0.2. Divide both sides by negative 0.02. Divide by negative 0.02. Solving for x, we get x of t is equal to 1 divided by negative 0.02 is negative 50. B e to a negative 0.02t. And minus 0.2 divided by minus 0.02, that's plus 10. So we get x of t, which is a mass of salt in kilograms at time t. This is equal to 10 minus 50b e to the minus 0.02t. Now, how do we solve for b? We apply the initial condition. The initial condition is x of 0 is equal to 30 kilograms. At time 0, we have 30 kilograms of salt dissolved in a tank. So on the left-hand side, we get 30. 30 is equal to 10 minus 50b e to the negative 0.02 times 0. So 30 minus 10, that's 20, is equal to minus 50b. And e to the 0, of course, is just 1. So solve for b, and we get b is equal to minus 2 over 5. Let's put b back in and solve for x of t. X of t is equal to 10 minus 50 times b, which is negative 2 over 5, e to the negative 0.02t. So simplifying this further, we get x of t is equal to 10. We've got 50 minus 50 times minus 2, that's plus 100 divided by 5. That's going to give us I guess that's 20, plus 20 e to the negative 0.02t. We have solved the differential equation, and this is the mass of salt in the tank at any time t. Part B of the question asked us, how long will it take for the concentration of salt to be reduced to 20 grams per liter? All right, so how do we do that? Well, we know that the salt concentration is, so let's write that salt concentration is equal to 20 grams per liter. Let's change that to kilograms. There's 1,000 grams in a kilogram, so we get 0.02 kilograms per liter. Now, we know the volume of solution in tank never changes. The volume of solution is always 1,000 liters because the rate that's coming in, the rate of solution that comes in is 20 liters per minute, is the same as rate of solution that's leaving the tank, which is also 20 liters per minute. So, let's reformulate the question and find the time when the mass of the salt in the tank will be 0.02 kilograms per liter, that's the concentration of salt in the tank, multiplied by the volume of the solution, which is 1,000 liters. So the question is, when will the concentration be reduced to 0.02 kilograms per liter? That's the same as saying, when will the mass of the salt in the tank be 20 kilograms? 0.02 times 1,000, that's 20 kilograms. So we have reformulated the question. So that means that we just have to solve for x of t, the mass of salt in the tank at time t, make it equal to 20 kilograms, and solve for the time when that happens. So we already have x of t. We solved the differential equation. X of t is equal to 10 plus 20 e to the negative 0.02t. X of t is equal to 20. Let's substitute that in. We get 20 is equal to 10 plus 20 e to the negative 0.02t. And subtract 10 from both sides, so we get 10 is equal to 20 e to the negative 0.02t. And divide by 20 both sides, so we isolate the exponential function. We get 1/2 is equal to e to the minus 0.02t. Log both sides, and we get log of 1/2 is equal to log of the right-hand side, log of an exponential, log cancels e, log of e to the negative 0.02t. So we get log of 1/2 is equal to log cancels e, and we get negative 0.02t. All right, so what we have is log of 1/2 is equal to negative 0.02t minus 0.02t. Let's isolate for t. T is equal to divide both sides by negative 0.02, and we get log of 1/2 divided by minus 0.02. So now we can simplify this. We can apply the log rule because log of x over y is log x minus log y. So let's write this as log 1 minus log 2 in the numerator, divide by negative 0.02. Now what is log of 1? Log of 1 is equal to 0. So we get minus log 2 divided by minus 0.02. Well, we get minuses cancel out. We get ln 2 divided by 0.02. That's just 50 log 2. The answer is 50 log 2. If we decimalize this, this is approximately 34.66 minutes. So it takes approximately 34.66 minutes for the salt concentration in the tank to become 20 grams per liter or 0.02 kilograms per liter. All right, so that answers part B. Now let's look at a summary of what we've done. So we have the diagram here, and it's always a good idea to draw a diagram to kind of visualize what's going on. We have 0.01 kilograms per minute of salt coming in. That's the concentration of, sorry, let me fix this. This should be 0.01 kilograms per liter of salt that's coming in, and it's coming in at a rate of 20 liters per minute. So when we multiply these two, the liters cancels out, and we basically get the rate in that's coming in, which is 0.2 kilograms per minute. 0.2 kilograms of salt coming in every minute. The rate of salt that's exiting the tank is going to be, what is the rate of salt that's exiting the tank? That's going to be the concentration of salt at time t multiplied by the amount of solution that's leaving, which is 20 liters per minute. So this setup is really the key. And a lot of times when students are doing this on a quiz or a test, it's very common for a student to make a mistake in this step here, setting up this part, the rate out, the rate of salt that's exiting the tank, the mass of salt in kilograms that's exiting the tank. So it's a little bit of chemistry. X over 1,000, this ratio represents the concentration of salt at time t, multiplied by the amount of solution that's leaving the tank, and we get the amount of salt that's leaving the tank. So let me just make a correction here as well, and the amount of salt that's exiting the tank will be X over 1,000, concentration of salt at time t, multiplied by the amount of solution that's leaving the tank, and we get the mass of salt that's exiting the tank. And now we create the differential equation. Rate in, this is the rate of salt that's coming in, mass of salt that's coming in every minute, 0.2 kilograms per minute. The mass of salt that's leaving the tank is 0.02x kilograms per minute. The initial amount of salt is 30 kilograms. That's how much salt is dissolved in the tank initially. And for part A of the question, we found the solution to this differential equation by separating out the variables, integrating both sides, and we get x of t is equal to 10 plus 20 e to the negative 0.02t. Now, just out of curiosity, what will happen as time goes to infinity? Well, as time goes to infinity, the negative exponential will die out. This component will go to 0 because e to the minus infinity goes to 0. So x of t, the mass of salt in a tank, eventually reaches 10 kilograms of salt as time goes to infinity. All right, thanks.